Good afternoon, my friends. My name is K. Samsaru. I study Department of Electronics, PBS College of Arts and Science. Today we are discussing about operational amplifier and its basic concepts. What is operational amplifier? Nothing but it is a direct coupled high gain. It is considered with differential amplifier or push-pull amplifier or complementary circuits. Op-amp is basically requires plus or minus 5 volts to plus or minus 22 volts. Let us discuss in brief. Discuss what is op-amp. Nothing but it is abbreviated as operational amplifier. Okay, it is a 8-pin, 10-pin or 14-pin package. In this we are discussing about 8-pin package. It look like basic symbol as plus 2. Around 8-pin package we are using only 5 terminals, 2, 3, 7, 4 and 6th pin. Okay, each pin act as different types. Nothing but 2 is inverted as inverting, 3 is act as non-inverting, 4th negative bias, 7th positive bias, and 6th one act as output terminal. Okay, op-amp can be work with plus or minus 5 volts to plus or minus 22 volts. Okay, op-amp can be integrator, differentiator, adder, and subtractor. Okay, let us discuss basically block diagram of op-amp. What is block diagram? In we are block diagram having 4 blocks. That is, first one acts as input stage, next one acts as mid stage, next one acts as level shifter, next one acts as output state. This is a block diagram. Internal we are having, and for input we are having 2 inputs, that is known as inverting. Another one is not inverting. It is used to provide it is used to take dual input and used to provide balanced output. Whereas mid stage it is used to take balanced input and provide unbalanced output. Level shifter means it is used to measure the DC voltage level with respect to ground. Next one, it is output stage. It is used to amplify the magnitude of voltage as well as current. In this, emitter follower circuits has been used. This is the block diagram. Okay, let us discuss the op-amp of inverting amplifier. What is meant by inverting amplifier means, inverting amplifier look like basically first take an op-amp and construct it and apply a resistor R1 across inverting, and we can apply AC as well as DC, and third pin has been terminal to grounded. A feedback resistor is connected from output to input state. Okay, next we are applying a current I1 across R1 and IF across RF. We are indicating an arrow that is known as double-headed arrow, nothing but virtual ground. Nothing but it does not allows current flows to ground. It flows across the terminals, nothing but R1 and RF. Now applying separate virtual ground to this terminal R1 and RF, separating this the 2 terminals. The input voltage was applied over here and output voltage measured over here. Nothing but I1 is equal to V1 by R1 and IF is equal to V0 divided by RF. This is the famous formula, Ohm's law, Y is equal to IR. Okay, apply KCL at node A. We can get the following equations. I1 is equal to IF, that is equal to V1 divided by R1, that is equal to V0 divided by RF. Nothing but V0 and V0 by V1, nothing but gain minus RF by R1. Now entire non-inverting amplifier can be as used as trans resistance or trans impedance amplifiers. Okay, entire this op-amps are used in closed loop applications. What meant by closed loop, I will tell you, we further discuss. Okay, next one. Now in this we are applying, if you apply AC signal like this 0 to 360 degrees, okay, we are getting an output is phase reversal. 180 degrees is phase shift can be obtained in inverting amplifier, whereas non-inverting same circuit being taken by we are giving a signal to non-inverting terminal, that is third pin we are applying to non-inverting terminal. Okay, nothing but AC signal is given to non-inverting, and a resistor R1 is connected across inverting terminal and it will be grounded. Similarly, a feedback resistor is RF is connected to ground 2 to 6, and 7th pin we are applying positive and 4th pin we are applying negative, and output we are measuring across output. Okay, next then apply KCL at node A. In this we are getting the formula nothing but gain is equal to 1 plus RF by R1. You simply calculate that. In this we are applying AC signal over here 0 to 180, and we are obtaining this phase and in phase, that is no out of phase will be obtained, in phase will be obtained in an inverting amplifier. Now you measure the value 1 plus maybe 22 kilo ohms by 10, that is approximately 3.2 value, whereas in inverting amplifier you are getting minus 2.2. Okay, next discuss about ideal op amp. What is meant by ideal op amp? We are taking the op amp without connecting our resistor. We are having some characteristics, switching some characteristics. That is, first one is input resistance is infinity. Output resistance is 0. CMRR infinity. Slew rate infinity. And bandwidth also infinity. These are the characteristics. Open loop gain also infinity. These are the ideal characteristics, basic ideal characteristics from basic op amp. Next one, summing amplifier. What is summing amplifier? The output voltage is proportional to the algebraic sum of one or more input voltages, nothing but one or more input voltages, that is nothing but operational amplifier. How can we conduct the summing amplifier? Summing amplifier, simply take the op amp. Okay, for inverting you used to apply 3 resistors R1, R2 and R3, and supply voltages are so V1, V2 and V3, so that the passing R1 across passing current is I1, R2 across passing current is I2, R3 is I3. Now non-inverting terminal has been grounded. The feedback resistor is RF is connected from output to input. We are getting a formula V0 is proportional to V1 plus V2 plus V3. We apply KCL at node A. This, by seeing the equation we can tell that output voltage is proportional to algebraic sum of input voltage. Next one important topic is integrator. What is an integrator? In op amp we are giving a feedback as a resistor, but instead of resistor used to keep over a capacitor. Okay, apply AC over signal here, and a non-inverting terminal is grounded. In this, capacitor is acts as a feedback. Capacitor means reactance of capacitor XC. XC can be written as 1 by j omega c, that is equal to 1 by SC, where S is present as Laplace notation. Okay. This is the integrator circuit. Applying KCL at node A, again R across we are applying I1, and C across again I2 or IF. Okay, by applying KCL, V1 by R1, another one is V0 divided by XC. In terms of time domain factor, we can write that V0 is equal to integral of V1 of t dt. By seeing the equation we can tell that output voltage is integral value of input voltage. Output voltage is proportional to integral value of input voltage. It is nothing but integrator. You apply a sign over here, we can get a square waveform as output for integrator. Okay, whereas differentiator by defining differentiator by simply interchanging the terminals. Interchanging terminals means by interchanging the terminals in an integrator R and C, we can obtain the differentiator. Non-inverting terminal has been grounded. 7th must be indicated. 7th means positive, 4th means negative. In every terminal you must indicate it, and 6th as output and R. Okay, again you separate the terminals C and R. with a double-headed arrow. Double-headed arrow means virtual ground that will allows current flows across the terminal. It will not flow across the goes to ground. Okay. In this we are I is famous formula. I is equal to dq by dt. Next q is equal to charge ultimate cv. Okay. V0 is equal to IR. Okay. You can I is nothing but dq by dt. That is equal to, you substitute over here your cv, that is equal to dq by d. In this v as indicated in input vi. Similarly, in terms of time domain, we can write as output voltage is proportional to difference of input voltage. Nothing but if you apply square over here in input, you can get as spikes. Nothing but differentiator. Next, move on to the next topic. Nothing but virtual ground. Virtual ground already we are taken, but already we are studied. But what in this we are studying at virtual ground means double-headed arrow. No, double-headed arrow same, but virtual ground over here we are applying in this virtual ground to every integrating or inverting circuits. Okay, so virtual ground. Virtual ground is nothing but a rail splitter. It needs a steady reference voltage. It is simply R1 or RF acts as an 2 raised voltage divider, 2 raised are connected in series. Entire this can be used as voltage to current and current to voltage converter and Miller theorem. Okay. This formula again gives minus RF by R1. Another one is voltage follower. It is a famous circuit. Voltage follower means output follows the input. Output follows the input. In order to check the op-amp is in good condition or not, we used to done voltage follower. That is 2 to 6. 2 to 6 we can 2 to 6 we are starting the terminal. Again applied 1 volt at 2 and we get 1 volt. That is op-amp is been working. We can, by using this op-amp we can do different practicals. This is the basic construction that followed by voltage follower. Another one is op-amp parameters. Op-amp parameters means op-amp parameters are input bias current and nothing but input impedance. It is the ratio of input by input voltage by input current, whereas output impedance is measured with no feedback. Okay. Another one is slew rate. Slew rate means is the ratio of change in voltage by change in current. Another one is input bias. Nothing but bias current is equal to common mode input current. It represented by IB, I plus I minus divided by 2. Another one is voltage gain. Voltage gain nothing but depends upon frequency, and the gain will be depend upon frequency. Okay, and this gain will be 82 up to 200 decibels. Okay, in this open loop gain we are used to having open loop as well as closed loop. Open loop means with no feedback and we can measure, and closed loop is measured by using with feedback terminal only. Okay, this is the basic parameters. Next move on to instrumentation amplifier. What is instrumentation amplifier means? It is a kind of differential amplifier that provides impedance matching. It can maybe used in mainly industries. It is used to for selectivity, resolution and sensitivity. Okay, and it is used to measure temperature, humidity, water flow. These are the basic needs. Basically acts as a transducer. Okay, another one is enter. It can be used data acquisition systems like radars, navigations, etc. Basically instrumentation amplifier is constructed by using op-amp only. Basically you take an op-amp. For inverting, you construct R1, R1 and non-inverting terminal has been grounded. Again, you construct a feedback with actually earlier you are connecting positive feedback. Now you connect as a negative feedback. Again, you apply meter over here and RS over here resistance and been grounded. Enter apply input voltage over here V1. Then by applying transfer function V0 by V1 is equal to RF by R1 into 1 by RS. Okay, by interchanging the RF from 200 to 100 kilo ohms, we can obtain full scale to half scale deflection depend upon resistor RF. Okay, similarly it can be used for AC as well as DC millivoltmeter. By interchanging elements, we can apply it for AC as well as DC. Okay, another one is zero cross detector. Another one is zero cross detector circuit. What is meant by zero cross detector circuits? Zero cross detector circuit means you again take an op amp. You used to take resistor R1 and V reference here. Again you take the resistors again R and V has been placed over here. We apply sine over here. It is used to convert sine waveform. It is used to convert sine to square waveform converter. Okay, op amp is in good condition or not, and zero cross detecting can be identified. If you apply a sine waveform like the positive or negative cycle, you used to get negative to positive. That means when the cycle conducts from positive cycle, the saturation will be upper negative. When you get a negative swing, you can obtain a positive swing. That is observed in zero cross detecting. Zero cross detecting are two types. First one is time marker. Next one is phase angle. Time marker means nothing but you give this entire circuit to an RC filter, RC low pass filter, so that in this the negative cycle will be clipped off. Only positive cycles will be we are getting an output. Whereas phase angle means only angles will be measured from 0 to 180 degrees. Next, move on to last topic today, comparator. Comparator means comparing between two inputs. Okay, comparing means how it will be compared. Take another diode like op amp. In this place the diodes in between them. Okay, again you connect R1, V1 and being grounded, and V reference being grounded, and output is taken across 6th pin. Okay, we compare between V in less than V reference, the output will be negative saturation. V in is greater than V reference, the output will be positive saturation. When V in is equal to V reference, the output voltage will be regulated from negative to positive. Okay, comparators are of two types, 311, another one is 339. In 311 we are connecting op amp to an transistor. The transistor can be on and off depend upon supply voltage. It can be operated with single supply or dual supply, plus or minus 15 or plus or minus 5 volts. Whereas 331 comparator we are having like AC, IC. In this we are having op amp will be like that. So means we are having 4 comparators inbuilt. If you conduct one, automatically it will draw power from all op amps. Okay, these have been chapters covered so far, topics covered so far. First of all, this is the op amp, basic op amp, ideal op amp, inverting, non-inverting. Another one is ideal op amp. Next one is inverting. Next one is integrator. Integrator also you can by simply adding a resistor or a capacitor we can obtain add to low pass, and differentiator we can obtain add to high pass filters. Okay, another one is virtual ground, voltage follower, op amp parameters, instrumentation, zero cross detecting circuit. Last one is comparator circuit. Okay.